Good day, viewers. You're welcome to this edition of our YouTube channel. And today we are going to look at another important topic in the mathematics of work. And that topic is called inverse variation. Now, when we talk about inverse variation, what that simply means is we are looking at the relationship between two variables. Let's say the relationship between two variables, either x and y or any other variable as the case may be. And as one quantity is increasing, the other one is increasing. As one is decreasing, the other is increasing. As one is increasing, the other one is also decreasing. Let's say if x is increasing, y will be decreasing. And if y is increasing, the other will also decrease. So you can see the relationship. As one is increasing, the other one is reducing, is decreasing. Now, with that being said, let's quickly look at the formula. There's no standard formula for this inverse variation. It depends on the way your question is being structured. And you're going to follow your question to generate the formula. Now, this is how it is done. If you have been asked a question like, if y varies inversely as x, or if y varies inversely with x, this is how you're going to generate your formula. This is what you're going to follow. You're going to follow your question accordingly. If it is y they call first, you are going to write the y first before you write the symbol of your variation, and then you move on. Can you see the way it is done? Again, if you also be asked, if x varies inversely, this is how you're going to start your question. X will also start it too. So you can clearly see for yourself. So with that being said, we'll go straight and start resolving questions. Now, for problem 1, it says, if x varies inversely as y, and x equal to 5, when y equal to 4. Problem 1a, find the connecting equation between x and y. Problem 1b, find x when y equal to 10. It is very, very simple. So this is what you're simply going to do. Remember, I did say earlier on that you must follow your question to generate your formula. So let's take it step by step. If x, they mentioned x first, so we are going to clearly write our x first. The next thing, if x varies, so I'm going to put the symbol. You can clearly see for yourself. There's the symbol right there. Varies inversely as y. So varies inversely as y. Remember your inverse, always 1 over. Now, with that being said, we have been able to generate this. Now, the next thing you're simply going to do from this angle is, you will come back here again, you write your x. Then the next thing I'm simply going to do, you see the symbol of alpha, this symbol here, you will turn it to an equal to sign. Then you will introduce a constant, let's say k. So it becomes k over y. And this is the formula we are going to use all through. So you can clearly see it for yourself. Now, with that being said, the next thing we're going to do right now is we are going to plug in these values into this formula. So wherever I see x in my formula, I'm going to put 5. And wherever I see y, I'm going to place 4. So let's kickstart the journey. Now, x, I will substitute the value. What's the value of x here? The value of x is 5. So I'm clearly going to write my 5 equal to k over, now what is the value of my y? The value of my y is 4. So whenever I see where I'm going to place 4 there. At this stage, what you simply do next, you have to cross multiply. And remember, I did say in our video earlier on that when you want to cross multiply, the top left will multiply your bottom right, and same. So 4 times 5 is going to give us 20. So our constant k is going to be 20. So you can see it for yourself. Now we have gotten the constant. Remember, we are not done solving. The question says, find the connecting equation between x and y. So what am I going to do next? Is very simple. I'm going to go back to this formula. Can you see the formula for yourself? Which says x equals to ky. I'll come down here and say x equal to, have you gotten your k now? Yes, I've gotten my k. My k is 20. So you go there and write your k, which is 20 over this y, and this automatically becomes your what? Your connecting equation. So we'll move to problem 1b. Now for problem 1b, the question says, find x when y equal to 10. Remember, it is this same formula you are going to use. So we'll come here, find x when y equal to 10. We'll go back and rewrite the formula, x equal to k over y. So now this is problem 1b. Did they give you x? No. So I'm going to rewrite my x equal to, do you have a k? Yes. What's your k? We already have k. Our constant is 20. So you come here and write the 20 over. Did they give you y in your question 1b? Let's check. They gave us the value of y, which is 10. So you're going to place it right here. At the end of the day, it is very, very simple. 10 here, 1, but 20 divided by 10. So my x, the value of my x is going to be 2. And this is the solution to question 1b. So you can clearly see it is done. It is very, very easy. Next, we'll move to problem 2. Now, for problem 2, the question says, if y varies inversely as x and x equals to 2 when y equal to 6, find the connecting equation between x and y. Now, at this stage, what you're simply going to do is very, very easy and very, very simple. The first thing I'm simply going to do, like I earlier said in our question 1, you follow your question to generate your words, your formula. So it becomes, your question says if y, so we're going to start with y. We follow it accordingly. Varies, so we're going to put the symbol. Inversely as x, so inversely as what? X. So you can clearly see for yourself the way we are following it step by step. The next thing you simply going to do from this angle, I'm going to rewrite the y and change this symbol to an equal to sign. They introduce a constant called k. So here become k over x. Now from this place, what am I going to do next from this stage? You are going to substitute the value. Wherever you see y, you're going to put 6. And wherever you see x, you're going to put 2. So what is the value of y? The value of y here is 6. So I'll come here and say 6 equal to k over, what is the value of x? The value of x is 2. So at the end of the day, if you cross multiply, 2 times 6 is going to, our constant is going to give us 12. So this is what we clearly have as our constant. Then next, we are not done solving. We are going to find the connecting equation. To find the connecting equation is very simple. You go back to this same formula and write it out. Here become y equal to, what is your constant? Our constant is 12. Our k is 12. 12 over x. And this becomes your connecting equation. So we quickly move to problem 2b. Now for problem 2b, the question says find y when x equals to 3. Again, we are going to rewrite this formula, which is y equal to k over x. Now, did they give you the value of y? No. We are going to rewrite the value of the y equal to, do you have a k? Yes, well, we did have a k, which is 12. So I'm going to write the 12 right there. Divide by, did they give you the value of x in your problem 2b? Yes, they did give us, which is 3. So at the end of the day, it becomes 12 divided by 3, which will give us 4. And this becomes the solution to problem 2b. Now for problem 3, the question says if y varies inversely as the square of x and y equal to 6 when x equal to 2. Problem 3 it says find the connecting equation between x and y. Problem 3b says find y when x equal to 3. It is very, very simple. So we're going to follow the formula accordingly in order for us to generate our, we're going to follow the question in order to generate our formula. If y, so I'm going to write y first. Next, varies, I'm going to write the symbol. Inversely as the square of x. Inversely as the square of x. Inversely as the square of x. So I'm going to put the square here. You can clearly see for yourself. So from this angle, what am I simply going to do next? Here is going to be y. I'm going to change this symbol into an equal to sign. Because y equal to k, introduce your constant over s squared. Now from this angle, this is the formula we're going to use all through. You can see how we normally generate our formula from your question. It's your question you're going to follow to create your formula. So with that being said, I'll go to problem 3a. Find the connecting equation between x and y. So let's go straight. Go back to your question. Wherever you see y, substitute this value, this 6, and place it there. So y is 6. I'll come here to put 6. Wherever I see y, equal to k over. Now, what is the value of your x? The value of your x here is 2. So I'm going to write it 2 squared. So we go and simplify further. Here becomes 6 equal to k. Now, 2 raised to the power of 2 is going to give us 4. So here becomes 4. At the end of the day, if you cross multiply, Here becomes 4 times 6, then k times 1 so here becomes k, the value of our constant becomes 24. So you can clearly see for yourself. Now from this stage, we are not done solving. Remember the question says, question 1a, question 3a says find the connecting equation. We are not done solving. So in order for you to get your connecting equation, it is very, very, easy. So what we're going to do next is this same formula, you're going to rewrite it. It becomes y equal to did they give you, do you have your constant now? What's your constant? Yes, we do have constant. Our constant is 24. So whenever I see k, I'm going to put 24 over your s square. So this becomes your connecting equation. This becomes the solution to question 3a. So quickly move to question 3b next. Up next, question 3b. Now for question 3b, it says find y when s equal to 3. So let's go back and take this same formula. The formula is y equal to k over s square. Now, did they give you y in your question 3b? No. I'm going to rewrite the y equal to did they give you, do you have a constant k? Yes, we do have a constant k. What is our constant? The constant is 24. So I'm going to come back and say 24 over, did they give you x in your question 3b? Yes, they did give us x. What's your x? Your x is 3. So I'm going to come here and put the 3 squared. So you can clearly see for yourself. So from this angle, what do we do next? Here becomes, we simplify for that. Here becomes y equal to 24 divided by, now 3 raised to the power of 2 will give us 9. So here becomes 9. So if we are to reduce this to the lowest thing, 3 here. So if 3 should go into 24, we're going to have 8. If 3 should go into 9, we are going to have 3. At the end of the day, we can either leave our answer this way, or we can also put our answer into mixed fraction. So 3 into 8 is going to go twice, which is going to be 2. Can you see for yourself? 2 number 2 over 3. So you see that you put your answer in a mixed fraction, you can also leave it this way. And this becomes the solution to question 3b. Now for problem 4. Problem 4 says if y varies inversely as x, when y equal to 1 over 2, x was equal to 3. Now problem 4a says find the connecting equation between x and y. Problem 4b, find x when y equal to 3 over 1 over 2. This is how it is clearly done. It is very, very simple. We're going to follow the formula. We're going to follow the question to generate our formula. If y, so I'm going to write my y first, varies inversely as x. At the end of the day, we're going to change this sign, this symbol here to an equal to sign. They introduce a constant, becomes k over x. You can see for yourself. Next, what am I going to do from this stage? Whenever I see y, what's the value of y? The value of y is 1 over 2 equal to k divide by, what is the value of x? The value of x is 3. So from this angle, what are we simply going to do next? We are simply going to do cross multiplication. So 2 times k will give us 2k equal to 3 times 1 is going to give us 3. At the end of the day, we are going to divide both sides by the coefficient of k. What that means is that we are going to divide both here and here using the number in front of this k. So if I cancel that, I'm going to have my constant as 3 over 2. Now from this angle, remember we are not done solving. We have to go and look for the connecting equation. In order for us to find the connecting equation, what are we simply going to do? We'll go back to this formula and rewrite it out. The formula becomes, look at the formula clearly. So the formula is y equal to, whenever I see my constant k in this formula, I'm going to write 3 over 2. Can you see for yourself? Divide by the x. So you can clearly see how it is, done. Now from this angle, what am I going to do next? For those of you who are used to fraction, those who have watched my videos on how to simplify fraction, what you're simply going to do from this angle, it becomes y equal to, this is 3 over 2. I'm going to write it 3 over 2. Can you see this divide line here? I'm going to write it this way, divide by x. At the end of the day, I'm going to reciprocate, so it becomes y equal to, this s will come down, so it becomes 3 over 2, and this division sign, if I reciprocate, it becomes, it will turn to multiplication sign, the s is going to come down, so it becomes 1 over x. So from this angle, what are we going to simply have? 3 times 1 is simply going to give us 3, then 2 times s is going to give us 2x, and this becomes my, this becomes my connecting equation. So with that being said, this becomes our connecting equation. This is the solution to problem 4a. So we go to problem 4b. For problem 4b, we are going to remember, we are going to rewrite this same formula, which is y equal to k over x. Now from this angle, what are we going to do next? Did they give you x? No, they did not. But did they give you y? Yes. What is your y? Remember, the y is still number 1 over 2. So what I'm simply going to do, I'm going to put it into an improper fraction. So it becomes 3 times 2, 6 plus 1, 7. So my y becomes 7 over 2 is equal to k. Now, do you have k? What's your value of k? The value of your k is 3 over 2. So again, I'm going to write the value of my k. Value of my k is 3 over 2. So it becomes 3 over 2 divided by x. Now, did they give you x? No, they did not. So I'm going to write the x here. Remember, like I earlier said, for those who have watched our videos, my videos on fraction, you will know what to do from this angle. From this angle, what am I simply going to do? I'm going to write my 7 over 2. Then set my equal to sign. This 3 over 2, I'm going to write it. This becomes 3, over 2. Can you see this division line? I'm going to write it this way. Then this x is going to be up here. If you reciprocate following the rule of Bodman, so what you're simply going to have is, I will have 7 over 2 equal to this x. If I reciprocate, this division sign will now come to multiplication sign. So it becomes 3 over 2 times this x that is up before will go down. Then you will have a 1 up. So it's simply going to be 1 over x. So let's go. 3 times 1 is going to give me 3. 2 times x is going to give me 2. So I'll have 7 over 2 is equal to 3 over 2x. From this angle, we are going to simply cross multiply. So we are not done solving. From this angle now, we are simply going to what? Cross multiply. So 2s is going to times 7. If 2s times 7, we are going to have 14x equal to, if 2 multiply 3, we are going to have 6. So from this angle, we say divide both sides by the coefficient of s. What that means is that we are going to divide both sides by the number in front of this x. So it becomes divide by 14, also divide by 14. So if we cancel out, we are going to have x equal to 6 over 14. Now, you can't leave your answer, your final answer this way. Reason being that, remember in fraction, your answer has to be reduced to the low. You always reduce your answer to the lowest thing. So check if any number can enter both sides. Yes, 2 into 6, we are going to have 3. And if 2 should go into 14, we are going to have 7. And this becomes the solution to question 4b. Up next, now for problem 5b, the question says if y varies inversely as x, when y equal to 13, x equal to 8. Question 5a says find the connecting equation between x and y. While question 5b says find x when y equal to 26. It is very, very simple. We're going to follow the question to generate our formula. If y, so I'm going to write my y first, varies, I'm going to write the symbol, inversely as x. So you can clearly see for yourself. The next thing I'm simply going to do for this angle, I'm going to turn this symbol to an equal to sign. So it becomes y equal to, I'm going to introduce a constant, k over this x here. So this becomes the formula I'm going to use all through. So from this angle, you start substituting the value. So whenever I see y, what's the value of y here? 30. So whenever I see y in my formula, I'm going to place 30. So here becomes 30 equal to k over, what is the value of s? 8. So whenever I see s, I'm going to put 8. At the end of the day, if you cross multiply, here is going to multiply here, while k will multiply here. So 8 times 13, I'm simply going to have my constant as 104. Now remember, you are not done solving, you have to find the connecting equation. To find the connecting equation, we simply need to go back and rewrite this formula. So what is my constant from this angle? My constant is what? 104. So what I'm simply going to do, go back to your formula in order for you to get your connecting equation. This is the formula. So here becomes y equal to 104 over x. You can clearly see for yourself. So this is the connecting equation. It is very, very easy. You go back and write your formula, and wherever you're having k, you substitute the value of k. So that becomes your connecting equation. So up next, we'll go to problem 5b. Again, before you solve any question, you have to go back to that formula you generated. So what's the formula? Y equals to kx. I'm going to write the formula y equal to k divided by x. Now, let's go to problem 5b. Did they give you x? No, they did not. But did they give you y? Yes, they did give us y. Our y is what? 26 equal to, do you have a k? Do you have a constant? Yes, we have a constant. What's your constant? Your constant is 104. So I'm going to write in 104 over your x. You clearly see how it is done over your what? Your x. So now from here, we are going to cross multiply. X times 26 will give us 26 x. Remember, I did say earlier on in mathematics, so you are being asked 2 times x, you say 2s. X times 2, you also say what? 2s. So x times 26 is 26s equal to 104. Now we are going to divide both sides from this angle. We are going to divide both sides by the coefficient of s, meaning we are going to divide here and here using the number in front of this s, which is 26. So it becomes 26x divided by 26 equal to 104 divided by 26. So you can clearly see how it is done. And if you cancel that, we are going to have x will be equal to, if 26 should go into 104, I'm simply going to have 4 as my answer. And this becomes the solution to question 5b. Now for question 6, the question says if p varies inversely as the square of q and p equal to 5 when q equal to 6, find the connecting equation between p and q. Why 6b? Find the q when p equal to 1.8. Now it's very, very easy. What we are simply going to do here is you are going to follow the question accordingly in order for you to generate your formula. So let's go. The first one says if p, so we'll write our p first, varies, I'm going to write the symbol, inversely as the square of q. So this is q square. Now with that being said, the next thing I'm simply going to do from this angle, you can see for yourself, I'm going to change this symbol to an equal to sign. So here becomes equal to, then I will introduce a constant k, and that k is supposed to be here. So if you look at it critically now, k times 1 in mathematics will give you k. So it will be k over q squared. So you can see for yourself. Now with that being said, we will go straight and start plugging each of these values. So wherever you see p, we are going to put 5. This becomes the formula we use all through. So what do I have as the value of my p? 5. So I'll come here and I'll write the 5 equal to k over. Now what is the value of q? The value of q is 6. So that becomes 6 squared. I'm following the formula. You can see the way it is clearly done. So the next thing you're going to do from this angle, we are going to simplify further. Here becomes 5 equal to k over 36, because 6 raised to the power of 2 will give you 36. So from this angle now, we can simply cross multiply. 36 times 5 will give me 180. So therefore, my constant k will be 180. Remember, we are not done solving because the question says find the connecting equation between p and q. That's the question 6a. We are not done solving. We have only gotten the constant. In order for us to get the connecting equation, what you simply need to do is to go back to that formula you generated, which is p equal to, now what is your constant? My constant is 180. So here becomes 180 over q squared, and this becomes my connecting equation. Now we will move to problem 6b. For problem 6b, we are simply going to rewrite this same formula again, which is P equal to K over Q squared. Now, with that being said, let's look at problem 6b. Did they give you Q? No, they didn't give us Q. Do we have a K? Yes, we did have a K. What's the K? The K is 180. So I'll say 180 over. Do we have Q? No, we do not have Q. Do we have P? Yes, we have P. P is 1.8. So here becomes 1.8 over. They didn't give us Q, so over Q squared. Now, from this angle, what you simply need to do, you can also cross multiply. Q squared will multiply 1.8. So I will have 1.8 Q squared. You can see for yourself, equal to 180. Now, from this angle, we are supposed to take the square root of both sides, but there's something common between 1.8 and 180. What is common is that 1.8 can go into this place, and we'll also reduce here using 1.8. So we'll say 1.8 Q squared divided by 1.8. I'm going to reduce both sides. And 180 divided by 1.8. If we do that, we are going to have Q squared is equal to, if 1.8 should go into 180, what I'm simply going to have will be 100. So at the end of the day, we are not done solving. What you simply need to do, you will take the square root of both sides, both here and here. And if I'm to take the square root of both sides, it becomes, take the square root of both sides. This root, we cancel this square up here. So I'll have only Q left. So here becomes Q equal to, if I take the square root of, if I should take the square root of 10, of 100, what will I get? The square root of 100 will give me 10. And this becomes my final answer. So you can see the way it is clearly done. So this becomes the solution to question 6b. This becomes the solution to question 6b. So let's tag it up here, 6b. So you can clearly see the way it is done.